All right, for geometry, we have 2.8 bisectors today. So we're going to approve and apply theorems involving bisectors of lines and angles. We're going to construct some perpendicular bisectors of segments and angle bisectors. So if we're going to construct them, you're going to need your compass and a straight edge. Okay, you're going to need those things today. All right, so recall that M is the midpoint of AB if we have A dash M dash B, remember that's the definition of between, so M is between A and B, and AM equals MB, or segment AM is congruent to segment MB. So notice we've got these, we've got our drawing here of AB, M is in the middle, and so we're saying that AM is congruent to MB here. So this is if A and B have coordinates, A and B respectively, AB is equal to the absolute value of A minus B. Okay, so this is the formula to find the length. Okay, notice we're recalling this. Okay, this is the length. I have no idea what I started to write there with a D. Okay, so this is the length formula. Okay, of how you can find length. So we're going to apply that here in example 1. It says find the coordinate of T if the coordinate of M, the midpoint of RT, is 2, and the coordinate of R is 5. All right, it's like, what? Okay, we're going to actually use this, a drawing here would be very helpful. Okay, we want to find the coordinate of T if the coordinate of M, the midpoint of RT. So notice we've got segment RT here. So we're going to do the segment RT. And if the coordinate of M, which is the midpoint, is 2. So we've got the midpoint here. Actually, let me move all of my letters to the top. Okay, that's one thing that would be very helpful is if you keep all of your letters on one side of your line and all the values on the other. So the midpoint, coordinate M, the midpoint is 2. So this is 2. And the coordinate of R is 5. So this is 5. So apparently I drew my line backwards. That's okay, we can go with that. Because now we can think, all right, well this is 5 to 2. So that means we have to have 3 and 4 in here. So in order to find the coordinate for T, we're going to need 2 numbers in there. So we're going to need a 1 and a 0, which would make this point -1, right? So we're showing that between here, 1, 2, 3, there's a distance of 3. So between M and T, there should be a distance of 1, 2, 3 as well. Okay, so this number is my distance to prove that M is my midpoint. They should be equal distances. So I can just use a picture here. Okay, so T could be -1. Or not T could be, T is -1. So it is at -1. Okay. Now, you could have also used this equation up there to help you, okay, because we have the length, okay, with the midpoint there. So there's a couple different ways that you could do that. But if I was looking at this, we might actually use the length later and just stick with the picture. So I want you to see like there's multiple different ways to solve it, but like if I ask for the formula, I want you to give me the formula or use the formula. Okay, so let's look at the midpoint theorem and then we're going to look at an example there. So the midpoint theorem, 2.8 there, 0.1. So with these, I'm not for sure, I'm sure I've showed you, this is from the theorem is from section 2.8, and then it's 0.1 because this is the first theorem that's given to you in this section. So we might have a 2.8, 0.2. The numbers don't really mean anything, it's just where we're learning them. All right, so the midpoint theorem says if M is the midpoint of AB, then AM equals 1/2 AB. Okay, so again, if we have AB and M is the midpoint, so both sides are congruent, okay, then we know AM equals 1/2 of AB. Well, that makes sense. We're cutting that section in half. Okay. The other thing we can use is to find the coordinate of the midpoint. M equals A plus B divided by 2. So if you're finding the coordinate, you can actually add the coordinate of A and the coordinate of B and divide it by 2. So like in our previous example, we found the answer to be -1. So we had R was at 5. So we could have said, all right, well, 5 plus -1 divided by 2, okay, to find the midpoint. That's 4 divided by 2, which would equal 2. And they told us our midpoint was at 2. Okay, so we could use these formulas to help us work backwards instead of drawing the picture. That's what we're going to do here on example 2. Find the coordinate of the midpoint M of PQ if P is at -15. So again, I'm going to go ahead and draw a picture. Okay. And they have a midpoint. Sorry, that should be a dot. They have a midpoint M. If P is at -15 and Q is at 7. So here's Q and here's point P. Then, so we're going to find the coordinates of them, of M. Then we're going to use the midpoint theorem. All right, so we want to find the coordinate of the midpoint. Okay, so there's a couple different ways that you can do that. You can find the length of these, like we talked about earlier, right? The absolute value. We could find the length of PQ, right? PQ is going to equal the absolute value of -15 minus 7. Okay, so -15 minus 7, that's the same thing as -15 plus -7. So that's going to be the absolute value of -22. Okay, which is 22. All right, that just means the length here. So the length from here to here is 22. Would you all agree with that? Like at some point we have to go up 15 to get to 0, and then we have to add 7 more, so that's going to give us a length of 22. All right, but if we know the length, then we could use this property, and we could know that PM is going to equal half, is going to equal 1/2 of 22. So again, this is the length, okay, of P to M is going to equal 11. So -15, we have to come back 11 to find the coordinate of M. So what's -15 if we're coming back 11? We're moving 11 to the right. Or -15 plus 11 would be what? Good, it'd be -4. So that's one way we can find the coordinate of the midpoint. But we also want to use the midpoint theorem to verify our result. So we're going to use this theorem. So our midpoint is going to equal the coordinate of P, which is -15, plus the coordinate of Q, in this case is 7, and we're going to divide that by 2. -15 plus 7 is going to give us a -8, divided by 2 is -4. So our midpoint is -4. Okay, there's, again, a lot of different ways. We're trying to teach you new formulas to find shortcuts, because you're not always going to have nice lines. They're going to be different shapes and other things as well. All right, then we have a definition down here. A segment bisector. Okay, a segment bisector intersects a segment only at its midpoint. Okay, so bisectors always cut it into 2 equal parts. Bisector. So bi is 2, right? Like a bicycle. So it has 2 wheels. When we have a bisector, we're cutting it into 2 sections, 2 equal sections. So any line, ray, segment, or plane forming right angles where it intersects a midpoint is a perpendicular bisector of the segment. So we can also have perpendicular bisectors. All right, then we're going to do a construction. So you need to get out your compass and your straight edge right now so we can look at those. I'm going to clear this while you get those out and ready. All right, to make this construction of your perpendicular bisector. Okay, so we're given AB, you see, and we're supposed to construct a perpendicular bisector of segment AB. It says using a fixed compass width, so we're just going to pick a width for our compass that's smaller than this. Doesn't matter, any fixed width. Okay, we're going to place the point of the compass on each endpoint. So I'm going to place it on N to start with, and we're going to draw intersecting arcs above and below the line segment. Okay, so I'm just going to go down here and draw an arc. I'm going to make it pretty big. I'm going to go to the top and draw an arc. Then I flip over to B and I draw an arc on the bottom, or the top and the bottom. Okay, hopefully I didn't move that. So notice I just have an arc on the top and the bottom because I put my end point on both ends and drew an arc. Now we're going to connect the intersections of the arcs. So see that intersection point and this intersection point? We're going to connect those to form a bisector. All right, so there's our bisector. It says connect the intersections to form a bisector of segment AB. Label the intersection of the segment and the line as the midpoint M. So this right here is M, the midpoint. That makes sense? We've got it. That was it. We drew a perpendicular bisector. Remember, perpendicular means that this is 90 degrees in there. That's what that perpendicular is. And the symbol for that is like the upside down T. Okay, so we just made a perpendicular bisector. All right, then let's look at another theorem here. We have congruent segment bisectors. Right? That just says if two congruent segments are bisected, then the four resulting segments are congruent. Okay, I'm not going to take the time to construct the bisector, but I am going to draw it on there. So if we have two congruent segments, x, y is congruent to KL, okay, and if these two congruent segments are bisected, so if we would draw a line between there, then the four resulting segments are congruent. So I would have XA is congruent to AY, which is congruent to XB, which is congruent to BL. Okay, that's our congruent segment bisector theorem. We went from two larger congruent segments to four smaller ones. Bisectors. Okay, divide objects into two equal parts. Okay, bisectors are always dividing into two equal parts. So if we have ray YT, so right here, ray YT is the angle bisector of angle XYZ. If YT is in the interior, so it's on the inside of angle XYZ, and we know the measure of angle XYT, so angle 1, is equal to the measure of angle TYZ, angle 2. So if that's the case, we can say, hey, this is an angle bisector. Okay, we know it's an angle bisector because it's on the inside and because angle 1 is congruent to angle 2. Otherwise, it would just be a ray that's in there. So the angle bisector theorem says if YT bisects angle XYZ, then the measure of angle XYT, so angle 1, is equal to half the measure of angle XYZ. That makes sense, hopefully, right? That if that's a bisector, the small angle is half of the big angle because it's an angle bisector. All right, great. All right, now the only other thing we're going to do is an angle bisector. We're going to construct an angle bisector. So you need that compass and straight edge again. Okay, so we're given angle A, and we're going to construct an angle bisector. So we're going to place the point of the compass on the vertex and draw an arc that's intersecting both sides of the angle. Okay, at points B and C, we're going to label them. All right, so I'm going to put my compass there. I need a little bit smaller here. All right, so I've got my two lines there, and I'm going to label them B and C, those points of intersection. Okay, step 2 then says, place the point of the compass on B and draw a second arc in the interior of the angle. So a second arc just on the interior, so somewhere in between there. Okay, so I know my lines would extend out here because it's a small angle, so that's why it has to be out here. Okay, maintaining the width of the compass, so I'm not moving its distance. I have to keep it equally measured. Place the point on C and draw another arc in the interior. Okay, notice how it wants to be intersecting the second arc that we drew. All right, now we're going to label the intersection of the two interior arcs as D. That's point D. And we're going to draw ray AD, the angle bisector. So I'm going to have to turn this a little bit so I can line it up best I can. Okay. So there is my angle bisector. I drew in ray AD. So remember, that means that this angle, CAD, is congruent to this angle, DAB, because I bisected it. I cut it into two equal parts, which gives us that last theorem here, the congruent angle bisector theorem. If two congruent angles are bisected, then the four resulting angles are congruent. Okay, so again, if we have, like say I have this angle, okay, is congruent to this angle. Again, pictures aren't drawn to scale, okay? They may be terrible, but I'm telling you they're congruent. So if these two congruent angles are bisected, so if I bisect this angle, which says this one is congruent to this angle, and I bisect this angle, saying this one is congruent to this one, which it clearly does not look it, right? But I'm telling you it is, then all four angles are congruent. Okay, so angle 1, 2, 3, 4. I could say angle 1 is congruent to angle 2, is congruent to angle 3, is congruent to angle 4. All right, so lots of things there. Okay, a little bit of constructions, more vocabulary. We'll apply it in class when I see you then. Have a great one.